We often view our megacities, towering skyscrapers, and advanced technologies as triumphs of human ingenuity alone. But the reality is quite different. We live in a world built on blueprints, inspired by nature. Stay until the end to see how the incredible kingfisher and the shark inspired our most advanced current technologies. For over 4 billion years, evolution has been the largest research and development laboratory in the universe. Every single animal, plant, and insect today is a survivor of rigorous evolutionary testing. Today on WildCircuit, we decode the software of life. Discover how animal bioengineering shaped our modern world through biomimicry, a discipline that replicates nature's brilliant systems to solve complex human challenges. Welcome to the circuit. Let us begin with one of geometry's most flawless structures, the honeycomb. If you had to partition a space perfectly using the absolute minimum amount of material while achieving maximum structural strength, what shape would you choose? When analyzing structural packing, circles inevitably fail, leaving useless, empty gaps between their borders. Squares and triangles do fit together, but they require redundant walls, forcing the hive to waste excessive amounts of material. The hexagon is nature's flawless mathematical masterstroke. It is the only polygon that offers perfect tessellation, maximizing volume while reducing the perimeter to its absolute minimum. Incredible as it seems, honeybees unlocked this supreme law of bioengineering millions of years before human mathematicians could even begin to calculate its efficiency. Today, this exact geometry drives modern aerospace engineering, from NASA's spacecraft panels to the walls of commercial airliners. This design is replicated everywhere. The result? Incredibly light designs that can withstand extreme pressures without failure. This is WildCircuit. And during the 1990s, Japan's high-speed rail network faced an unprecedented engineering crisis. The iconic Shinkansen bullet train was pushing the boundaries of speed, reaching an incredible 300 kilometers per hour. However, a severe aerodynamic phenomenon emerged. As the massive trains surged through narrow mountain tunnels, they compressed the air ahead of them like a piston in a cylinder. Upon release, all this compressed air created a sonic boom and a shock wave that disturbed the peace of many people in the surrounding area, creating a huge environmental obstacle for the project. The engineer in charge, an avid birdwatcher, turned to the kingfisher for a solution. This remarkable bird dives from the air into water, a vastly denser medium, at high velocities with barely a splash, thanks to the flawless aerodynamic design of its beak. But translating a bird's biological blueprint into a massive steel locomotive presented an incredible challenge. Standard aerodynamic models failed to solve the intense drag, forcing the team to precisely replicate the structural geometry of the kingfisher's beak. The resulting nose cone design was an absolute triumph. It didn't just eliminate the deafening sonic boom entirely, It allowed the train to slice through atmospheric pressure seamlessly. The Shinkansen became 10% faster, while remarkably reducing its power consumption by 15%. Our next destination takes us deep into the ocean. Sharks are the ultimate apex predators, but their greatest secret lies not in their teeth, but in their skin. Under a microscope, a shark's surface reveals millions of overlapping microstructures called dermal denticles. This flawless texture drastically reduces hydrodynamic drag, allowing them to slice through the water with absolute energy efficiency. But medical engineers discovered an even greater potential. Bacteria cannot adhere to this nanostructure either. It's not a chemical defense, it's pure geometry. The microscopic pattern is so dense that pathogens cannot find a flat surface to multiply. Today, advanced hospitals use synthetic coatings that mimic shark skin to keep surgical areas bacteria-free, eradicating infections without a single drop of chemical disinfectants. From the perfect hexagonal architecture of honeycombs to operating rooms sterilized by the design of a shark, we've seen how our megacities and most advanced technologies can be the product of plans inspired by nature. The circuit of evolution is perfect, and we are only just learning to turn it on. If you've made it this far, we invite you to follow the channel to continue learning with us about animals and science.